Okay, for the question 1A, sketch the graph of the curve of intersection between the cylinder x squared plus y squared equal to 9 and the plane y plus z equal to 3. Then find a vector function RT that represents the curve traced out by the graph. So first step, we must let x equal to r cos t, y equal to r sin t. Then from the equation of cylinder x squared plus y squared equal to 9, we get r squared cos squared t plus r squared sin squared t or equal to 9. Then we get r equal to 3. Then from the equation of the plane y plus z equal to 3, we get z equal to 3 minus r sin t. Then we can write the curve of RT as 3 minus 3 sin t, which is a vector valued function of a single variable theta. Then we get graph like this. Okay, for the question B, find the point of intersection between the curve RT and the plane 2x minus y plus z plus 1 equal to 0. So the solution is, as we know that from RT we can get this one is x, this one is y, and this one is z. So we substitute it into the equation of the plane. Then we get like this. Then from that we can get T1 and T2, which is T1 equal to -1 and T2 equal to 1. Then after we get T1 and T2, we substitute it back into the RT function. So when RT1, we get the intersection point is 0, 0, -1. The intersection point of RT2, we get 0, 2, and 1. Okay, for the question C, find the values of P for which the vector GT satisfy the differential equation d squared g over dt squared plus 16g equal to 0. So first step, we must differentiate the GT. Differentiate GT, we get -3 p sin pt plus 3p cos pt. Then we must differentiate again. Then we get -3p squared cos pt minus 3p squared sin pt. Then when we get double differential and GT, we substitute into the differential equation given, like this one. And then when we substitute, we get this one. Then we can solve it until we get P. So P squared equal to -16. For the question 2A, at time t equal to 0, an object is located at the origin and has a velocity of I minus 1 over 3j plus k. Find the velocity and position vector of the object if at any time t the object is moving with an acceleration at equal to ti plus e power of -3t j plus sin tk. Find. Okay, from the question we know that v0 is equal to I minus 1 over 3j plus k and at as a given. Then first, to find the velocity, we must integrate at dt. Then we get velocity t squared over 2 I minus e power of -3t over 3j minus cos t k plus c. Then we get v0 equal to -1 over 3j minus k plus c. Then we compare with v0 from the question, and like this one, -1 over 3j minus k plus c equal to I minus 1 over 3j plus k. and then V0 we get I plus 2k. Then we substitute back in the velocity. Then we get velocity is like this one. For the position of vector, we integrate the vt dt. Then we get this t cube over 6 plus t I plus e power of negative 3t over 9j minus sin t minus 2t. Okay, for the question 2b, the parametric equation of a curve are given as this. Find its unit tangent vector and unit normal vector for the curve. So from the question, we know that RT is equal to e power of t cos t I plus e power of t sin t j plus 2e power of t k. So to find the unit tangent vector, this is the formula. First, we must differentiate the RT, and then we get this one. Negative e power of t sin t plus e power of t cos t I plus e power of t cos t plus e power of t sin t j plus 2e power of t k. Then we must find the magnitude of r prime t, and then we get square root 6 e power of t. So we substitute it back into the formula of unit tangent vector, and then we get unit tangent vector as this one. So unit normal vector we can find using this formula, which is n equal to unit tangent vector prime over with magnitude of unit tangent vector prime. So unit normal vector we get this one, 0.186 in bracket minus cos t minus sin t I plus 0.186 in bracket cos t minus sin t j. Okay, for the question 2c, based on the Sernet-Serret formula, find the torsion if the unit binormal vector bs and unit normal vector ns in term of arc length as given as bs and ns. This is the Sernet-Serret formula, and this one the formula for torsion. And first we must find the dv over ds, and we get 2 over square root 5 in bracket 1 over square root 5 cos 5 over square root 5 I plus 2 over square root 5 in bracket 1 over square root 5 sin in bracket 5 over square root 5 j. And then we can find the torsion by using this formula, and then torsion we get 2 over 5. For the question 3a, given the scalar field fxyz equal to 2x cubed yz. First question, we must find the grade f. This is the formula for grade f, and then we get grade f as like 6x squared yz I plus 2x cubed zj plus 2x cubed yk. Then for question A2, evaluate the directional derivative of f at point -1, 1, 2 in the direction of PQ, given that P 3, 2, 1 and Q 2, -1, 3. First, we must find the grade f at point -1, 1, 2, and then we get 12i minus 4j minus 2k. Then we find v, which is point q minus point p, and then we get -1, -3, 2. Then we find the magnitude of V, and we get square root of 14. Then we find unit vector U, and then we get negative 1 over square root 14I minus 3 over square root 14J plus 2 over square root 14K. Then the directional derivative is equal to negative 1.069. For question A3, determine the direction in unit vector for the maximum rate of change of f at point -1, 1, 2. Maximum directional derivative is equal to grade f equal to 12I minus 4j minus 2k. B. Given a solenoid vector incompressible fx as a given, where alpha and beta are constant, find the values of alpha and beta. First, as we know that solenoid vector incompressible is equal to die f equal to 0. So we must find the die f. This is the formula, and then first we must differentiate to x z sine alpha y z in terms of x, and then we plus with byz plus cos 2yz differentiate in terms of y plus negative 3z squared over 2 differentiate in terms of z equal to 0, and then we solve it until we get to z sine alpha yz plus beta z minus 2z sine 2yz minus 3z equal to 0. Then we compare it like 2z sine alpha yz equal to 2z sine 2yz. So we get alpha equal to 2. And then we compare beta z equal to 3z. And then we get beta equal to 3. For question 3c, let r x y z equal to xi plus yj plus zk. And r equal to r x y z equal to square root x squared plus y squared plus z squared equal to magnitude r. C1, prove that grade r power of n equal to n r power of n minus 2 r. This is the formula to search grade r power of n. Then from the equation, in the question, r squared equal to x squared plus y squared plus z squared. We differentiate it in terms of x, we get dr over dx equal to x over r. Then differentiate in terms of y, we get dr over dy equal to y over r. Differentiate it in terms of z, we get dr over dz equal to z over r. Then we differentiate r power of n in terms of x, we get xn r power of n minus 2. We differentiate rn power of y, we get yn r power of n minus 2. To differentiate r power of n in terms of z, we get zn r power of n minus 2. Then grade r power of n, we get xn r power of n minus 2 plus yn r power of n minus 2 plus zn r power of n minus 2. And then the last one, we get n r power of n minus 2 r. So proof. For question C2, grade multiplied with r power of n r equal to 0. So this is the formula of grade cross r power of n r equal to grade cross r power of n xi plus yj plus zk. And then we calculate it like usual until we get equal to 0. So proof.
For question number 4a, they ask us to evaluate the integration of 3y squared over square root of 4y squared plus 1 ds, where curve C is x equal to 1 minus y squared from point 0, -1 to point 0, 1. So we need to find the RT from the point given. So we'll find the RT is 0 to t minus 1. Next, we need to find ds, which is magnitude of r prime t. So here we will get r prime t is 0, 2. Then ds we will get 2 dt. Next, from RT, we need to find the limit for t. So we take y is equal to 2t minus 1. Substitute y0, which is -1, and we will get t0 0. Substitute y is equal to 1, and we will get t1 equal to 1. So our limit of t is from 0 to 1. Then from the equation, make y as the subject, so we will get y is equal to square root 1 minus x. So substitute the y into our function here, and we will get this function for our next integration. So for the next integration, we integrate from 0 to 1. Function will be 3 minus 3x over square root of 5 minus 4x dot 2 dt. Here is actually ds. So ds is equal to 2 dt. Then we just integrate like usual, and we will get 6 over square root of 5t. Before we substitute the limit. So after we substitute the limit, we will get the answer is 6 square root of 5 over 5. For question 4b, we need to find the work done. And first given is 2x plus yi plus y squared j plus y plus zk from point A 251 to point B 174 along curve RT is equal to 3 minus ti plus 2t plus 3j plus t squared k. So we already have the RT. We just need to find the dr over dt. dr over dt is equal to -1 to 2t, and dr we will get -1 to 2t dt. Next, we take dx is equal to 3 minus t to find the limit for t. So we substitute dx with x0 equal to 2. So when x0 is equal to 2, we will get t0 equal to 1. Then when x1 is equal to 1, we will get t1 is equal to 2. So the limit for t is from 1 to 2. Next, we integrate the f.dr. So we just substitute the limit for t, which is from 1 to 2. And function, and substitute the limit and function into the formula here. So we also substitute the dr is here. Then we integrate like usual, simplify the integration, and we will get here t power of 4 over 2 plus 4t power of 3 plus 15 t squared plus 9t. It is before we substitute the limit. So when we substitute the limit, we will get 89.5. For question 4c, given a vector field f is equal to 3x square plus y power of 3 zi plus 3xy square z plus yz power of 4 over 2 plus 3yj plus xy power of 3 plus y square z power of 3 plus 4zk. First question, we need to show it as is a conservative field and find its potential function. To show conservative, we need to show that curl f is equal to 0. So we just use the formula where we substitute f1, f2, f3 here, where we get the f1 here, f2 and f3 here. So after we simplify, it is shown that curl f is equal to 0. So means it is a conservative, f is a conservative field, and we need to find its potential function. To find potential function, we need to integrate f1 with respect to x, f2 with respect to y, and f3 with respect to z. So after we integrate, we will get this for f1, f2, f3 potential function. And to summarize the potential function, total potential function, we don't take the repeated value. So we just take once. For example, here is x3, x power of 3, xy, x power of 3 plus xy power of 3z. We just take once, so we don't take this, plus y square z power of 4 over 4. We don't take this, plus with 3y square over 2 plus 2z plus c1, c2 and c3. So we simplified the constant there, where c is equal to c1 c plus c2 plus c3. So total potential function, we will get this. For question 4c2, we need to evaluate the def.dr, where C are line segment from point 2, 3, -2 to 3, 4, -1, then to 1, -1, 3. Okay, let's say it is point P, Q, and R. So first, we need to substitute the point into the potential function. Then we will get here. This is for point P, this is for point Q, and this is for point R. So when we substitute the point into the phi, we will get this 3 potential function. So f.dr, integration of f.dr is actually the subtraction of 2 points, which is for the first one is Q minus with P, potential function of Q minus with potential function of P, plus potential function of R minus with potential function of Q. Then after we substitute the potential function into all of the point, we will get here. Then we simplify the equation. Last, we will get 80.25. Next is for question number 4D. Use Green's theorem to evaluate 3x power of 3y plus ln 3x square dx plus 5x power of 4 over 4 minus sine 3y square dy, where C is a closed curve bounded by y equal to x square and the straight line y equal to x plus 3 in an anti-clockwise direction. So first we need to sketch the graph for y equal to x square and y equal to 2x plus 3, and we'll get the graph as here. Next we need to find the limit for x, so we just take y1 is equal to y2, and we will get here. So actually this is the intersection point of straight line and curve. The intersection point is the limit for x, which is from -1 to 3. Next, for Green theorem, in the Green theorem is equal to integration of df2 over dx minus df1 over dy dA. So first we need to find the df2 over dx from f2. So df2 over dx is equal to 5x power of 3. Next, find the df1 over dy, which is equal to 3x power of 3. Then substitute into the Green's theorem. Next, for the limit, we have known that a limit for y is equal to x power of 2 to 2x plus 3, and for x we got from -1 to 3. So for dA, dy has an unknown x, so we put dy inside and dx outside. So we just integrate like usual. First for dy, so substitute the limit. After integrate, we substitute the limit for y and do the integration once again with respect to dx, and substitute the limit for x, -1 to 3, and we will get the answer 1088 over 15. Okay, next for question 5a, evaluate surface integration of z ds, where cone z is equal to 2 square root of x square plus y square, which lies between plane z equal to 4 and z equal to 2. First, we need to sketch the cone and the plane z equal to 4, z equal to 2. Sketching will be like this. And next, we need to find the main function for the integration. So we'll choose xy plane and it will be sketched like this. It should be sketched like this. Next, we need to find ds over dA, where ds over dA is equal to magnitude of divergent f. Where we can find the f is from the equation of z. Remove this equation here and it is equal to 0. So we will get f is equal to z minus 2 square root of x square plus y square equal to 0. So from the f we can find the divergence of f and magnitude of divergent f. ds is equal to magnitude of divergent f dA, and ds we will get square root of 5 dA. Next, we need to integrate z ds, where z, we found it from the equation, is equal to 2 square of x square y square. And ds, we just substitute this into here. For dA, we change it into r dr d theta because from the xy plane we got a circle here, so it is easy for us to integrate. And for r, we will get from the two planes z equal to 2 and z equal to 4, when we sub z into this equation, z equal to 4 and z equal to 2, we will get r equal to 2 and r equal to 1. So the limit for r is from 1 to 2. And for theta, we will get 0 to 2 pi because it is round circle. So from the equation, x square plus y square is equal to r2. So we just change all the equation into dr d theta, so we can integrate it easily. Next, we just integrate like usual with respect to dr and with respect to d theta. At last, we will get the answer 28 square root of 5 over 3 pi. For question 5b, evaluate surface integral f dot n ds where f is xi plus yj minus 3k and parabola z is equal to x square plus y square for z is from 0 to 4. First, we need to sketch the graph for paraboloid. And we'll get this. Z, while z is equal to 0 to 4. Next, from the equation, they ask us to evaluate the integral of f dot n ds. F dot n ds is actually equal to f dot divergent phi dA. So how we want to get the phi? It is from equation of z. Just move the equation here and we will get the phi. Phi is equal to z minus x square plus y square. And next, we need to find the divergence of phi. Then why it is negative here? Because from the paraboloid, we will get downward normal vector. So when it is downward, it will be negative oriented. So it is why negative is here. So from this formula, we need to find the dot product of f dot divergence of phi. So dot product is here. Next, we just need to integrate. So since it is dA here, we change it into the r dr d theta because it is easy for us to integrate. We use dr d theta. So we change x and y into the term of dr d theta into r and theta. For limit of r is from 0 to 2 because we get from the equation of paraboloid, and we get it from z, from this z, where it is from 0 to 4, and here is equal to r square. So we will get the r is from 0 to 2. For we'll get, for theta we'll get 0 to 2 pi because it is circle up the paraboloid. And we just integrate like usual with respect to r with respect to theta. And we will get the last answer is 76 pi. Okay, next for question C, if f is equal to 3xy square minus EYI plus y power of 3 minus cos zj plus e2x minus tan yk, use Gauss theorem to evaluate f dot n ds, where it is closed surface and solid bounded by the plane z equal to 0, x plus z equal to 3, and cylinder x square plus y square equal to 4. So from the equation, we need to sketch the graph of cylinder and plane, and we will get sketching is like this. Yeah, we know that f dot n ds is equal to divergent f dv. So first, we need to find the divergent of f. Divergent of f is equal to delta f1 over dx plus delta f2 over dy plus delta f3 over dx, and divergent of f, we will get this one, 6y power of 2. Next, we just integrate where integrate y square dv, 6y square dv, so dv, we change it to dz dr d theta, so we can easily integrate the equation. So for limit of z, we'll get from the equation z is equal to 0 and z is equal to 3 minus x. Since we have changed it to dr d theta, we need to change the limit for z too, so it will be negative r cos theta plus 3. And for limit r is from 0 to 2, also we get from the equation from this cylinder where x square plus y square is equal to 2. X square plus y square equal to r square equal to 4. And we will get the limit for r is from 0 to 2. Next, for theta is from 0 to 2 pi, because we see a circle up here, and we just integrate like usual. It's quite long integration because we need to integrate 3 times with respect to dz, with respect to dr, with respect to d theta, and the last answer we'll get is 36 pi. And for the last one, 5d, let f is equal to negative y power of 3 plus 10xi plus x power of 3 plus eyj, and c is the positively oriented boundary of the portion of the hemisphere z equal to square of 4 minus x square minus y square above the plane z equal to 1. So we need to evaluate f dot dr by using Stokes' theorem. So first, we need to sketch the graph for hemisphere, and plane z is equal to 1. So question give us to evaluate f dot dr, right? So we change it into integral of curl f dot n ds, like this. Like this. Okay, first we need to find the curl f, cross product of f. So cross product is just substitute f1 here and f2 here. and we will get cross product is 3x plus 3y. For n here, we can find it from divergence of phi, where we can get divergence of phi from the equation of hemisphere, and phi will get z minus square root of 4 minus x squared minus y squared. So we will get the divergence of phi like this. Next, we just substitute the curve f into the equation and the divergence of phi into this equation dA, where dA we use r dr d theta because easy for us to integrate, because it is a hemisphere here. I will have a circle. So for limit for r is from 1 to 2 from the equation, because from the equation of hemisphere we substitute z with 1 here, and we will get the r, because x squared plus y squared is equal to r squared, so we will get the r, and the r is the limit for r is from 1 to 2, and for theta limit is from 0 to 2 pi because it is hemisphere. Then we just integrate like usual with respect to the r and d theta. We will get the last answer is 26 pi.